is in fact representing a reality on average, which is this 70%, but it's going to be wrong during recessionary period and going to be wrong during benign periods. Okay? So this is the reason why, and we're going to go deeper into this, but this is the reason why, in fact, the assumption on the covariance matrix is so important, because it is not something that I can consider as a given once forever. And if you remember, whether I'm looking at the Markowitz optimization, whether I'm looking at the CAPM, whether I'm looking at Black-Litterman, I'm always considering a covariance matrix that is a given that has been estimated statistically. So this is a big weak point here, and there isn't a right or wrong approach to estimating it right. Right, now we're going to go a bit deeper into this. So what I have here is, in fact, the various portfolios, assuming that I am on the efficient frontier and with different levels of risk. So, in fact, at the beginning here, the first portfolio is the least risky, and the last portfolio is the most risky. What I find here with this is that when I do a mean variance optimization, in fact, very few assets contribute to the allocation. Only the assets which have got a best risk-return balance. So, for instance, when I had some of the assets historically that had a poor risk-return performance, they were completely exited. So if you remember, commodities was a good example where it did very poorly, commodities. So commodities doesn't exist in my portfolio. So what I'm saying is that whatever is the risk level I'm aiming for, I'm going to have a very limited number of assets. So in a way, I am absolutely certain of the outcome, therefore, why diversify? And this is something that is a big mistake in the sense that, in fact, the degree of certainty I have from a forward-looking perspective is not at all what I have seen historically. And if you remember the table we went through on the first lecture, when we look at the relative positioning from one year to the other of the various asset classes, in fact, there is no pattern that is a clear pattern. So it's very difficult to have a high degree of certainty. Whereas when I'm using either a 1 divided by n portfolio or a random portfolio, I'm going to have a much more diversified portfolio. Hence the idea that a 1 divided by n portfolio can do quite well is because the 1 divided by n is the best portfolio to cover my ass, if I'm a bit colloquial, in the sense that I don't know a lot about this. As a result of that, I don't make concentrated bets, and which is probably better because I know much less than I assume through this model. Sorry, I'm looking for a bit of water. It's going to come in a second. What I did with it. Yes, here it is. So you can see why we're taking much bigger risk through the optimization here. So, and another way to say it is let me consider on a given year the positioning, the relative risk-return positioning of the various assets. What you can see is that my efficient frontier, I may have 9 assets, but my efficient frontier is going to depend only on 3 assets, which are the assets getting the best risk-return. Okay? So all these assets I have here are irrelevant. I don't need to hold them because they are not considered as well-performing assets. Therefore, I ditch them. Now, let us have a look at this, which is quite stunning. What I'm doing is I'm taking 4 years of history to compute the risks, and so the return, the historical return, and the historical volatility. And I'm computing the efficient frontier after taking for granted that I have got 4 years of history to have a clear idea of the historical returns of these guys. What you can see is that every year, the efficient frontier varies considerably. Okay? So in fact, I cannot say, and here starts some of the difficulties, is I cannot say that, in fact, the risk-return efficient frontier I have in a given year is repeatable and reusable on a different year. It is actually so different that the optimization given what I thought was right is going to differ completely from what I had on the previous year. So not only the problem here is that I'm making the assumption that I've got a high degree of certainty on the returns of the assets, and as a result of that I concentrate my efficient frontier based on a few assets that make the efficient frontier. But what I find is that there is absolutely no stability of the efficient frontier because the core drivers in terms of return of the efficient frontier tend to vary very much from one year to another. So if I'm making the optimization to be on the efficient frontier this year, and if next year is based on this, an allocation that is completely different, I'm going to mix it up completely. Yes, please do.
So, recognizing that for the efficient frontier.
So it's exactly, so what is going to happen if I take 4 years of history? Okay, I have got emerging equity here.
Yes, that can move, right?
That will move, and so what means if during 1 year, you know, typically with the mean reversion in the market, I've got 3 years that suck.
Yeah.
The 4 years is going to explode completely.
Yeah.
Therefore, in fact, what happens is that this period, over this period of 4 years, here is the picture, and then afterwards this one collapses, that one goes completely differently, because in fact all of this is completely irrelevant. But assuming that hedge funds 1 year is in big trouble and this one gets here, then the shape of the efficient frontier is going to vary completely.
Right. I'm just asking because you said you looked at the various years.
Yeah.
How did the composition change? Was it like systematic or?
Yeah, well, actually here you've got, I understand what you're saying. I mean, we could get back to all the various assets, but here is the outcome, and the shape is very different from 1 year to the other. It doesn't mean that, I'm not saying that unless you've got a big crisis, typically when you've got 2008, it's all over the place. It's probably not that, if you look at actually, because it's not super easy, but what you have here is you've got the lighter colors, okay? So the lighter colors tend to be here, okay? So they're varying here, but then what you see is you see in the end a shift to the darker colors, which are shifting up, okay?
Yeah, it follows just the return to market.
Exactly, exactly. Everything okay? And here is what happens, is that in terms of this is my efficient frontier ex ante, and what happens is that typically what I'll find is that ex post, the returns of the assets are going to be there. And so what I thought in the optimization I did based on the ex ante, what I find here is ex post, a completely different picture, because I'm going to put a lot of weight on the highest performing assets, which is not going to be very relevant here. Okay? And it can be even, I've kept the slope positive, but if I didn't keep the slope positive to have this guy actually keeping its volatility level but getting here, then I've got something that is becoming much more complex. And so this is it here. What I have is that when I'm making, I'm using the first 10 years of my sample to build the history and the historic and the efficient frontier. When I'm using that on the second half, in order to make some investment decisions, I'm getting something that is much poorer than based on the historical decision I made. Okay, so in fact, what it means is that really the historical information I can use is in no way informative to the point that I can make decision and in addition concentrate my bets because these few assets in which I trust deliver. It's not the case. Actually, there is another thing that is quite stunning, which is if I'm aiming for that we observed, if I'm aiming for a 6% return ex ante, and I'm using the approach, what I found is that at the beginning, in the early 90s, we had something that was doing ex post reasonably well. The more we go into the crisis period, the less it works. One element of explanation in this is that actually at the beginning, when not everybody was working on portfolio construction, like we saw, the various asset classes were rather uncorrelated. And the more people are doing that, the more they become correlated, and the less benefit of diversification there is. And in fact, when you have a diversified portfolio, what happens, less correlated, is you tend to have in your recipe, optimized recipe, quite a lot of various assets. When they become concentrated, you don't need many. Okay, so you concentrate your portfolio even more when you've got a highly correlated portfolio. As a result of that, you're getting it, the outcome is getting worse and worse. So this explains why, in fact, whenever you're dealing with this, you have got that. So one of the points that we discussed was this. If I'm trying to build a portfolio from equities, okay, this portfolio I build from equities, the equities are going to be highly correlated generally. The more I'm getting into a crisis period, the more I'm getting, in fact, something through my portfolio, which is going to be the market. So when the market collapses, what happens is that I may think that I'm getting the benefit of diversification historically, but suddenly I've got a market collapse. Everybody moves together. And as a result of that, in fact, it is just as if I were holding one stock. So this is something that is quite important. The benefit of diversification is something that you get when you are in benign market conditions, but it is not something that you get when you're getting into tough market conditions. And hence here, when we're getting to the 2008 situation, it's really a train wreck, because in fact we haven't got any benefit of diversification, and we are highly concentrated based on very strong beliefs, and it doesn't work. Actually, you could say, okay, so far what we've been doing is we've been looking at the Markowitz optimization. In the Markowitz optimization, we have that level of concentration because we pick the best assets on the efficient frontier. What we should say is, wait a minute. Now, when I look at the equilibrium returns, with the equilibrium returns, I've got more diversification, because what I'm going to have is I'm going to have the holdings in the market that the holdings in my portfolio that more or less correspond to the holdings in the market. So therefore, I cannot build a portfolio just with hedge funds, or I cannot build a portfolio just with bonds. I have to hold a bit of everything. But here, in fact, it doesn't, again, the difficulty, so here is what the various asset classes I have, is that whenever I've got a big crisis, my portfolio, this portfolio corresponds to actually different degrees of risk return. Okay, the highest, the most risky portfolios are the portfolios that actually go down the most. And the less risky portfolio, the least risky portfolio, is going to be the black portfolio. The black portfolio is the market portfolio, and the bold gray portfolio is the one that corresponds to my 6% return. What I find is that although with a market portfolio I am more diversified, whenever there is a bit of a crisis and all the assets converging, then I'm not protected either. So you can see that, in fact, it's going to be even less well than the one divided by N portfolio, the one divided by portfolio being more diversified than a market portfolio. So this is the reason why in the literature you find the idea that it's very hard, and it is indeed very hard to beat the one divided by N portfolio, because it is the most diversified portfolio. And in fact, every portfolio that includes a view, if it is a backward-looking view, then there is no reason that it should perform reasonably well. The worst being the optimized, mean variance optimized. The guys in the middle is going to be the market portfolio, and the one divided by N being the most stable. Okay? But with that, it's not very exciting in the sense that the toolkit I have built is quite useless. So now what we're going to do is we're going to go one step further to understand why what we can do, why it's not delivering, and what we can do to get away from this dead end. One of the things here is important, which is the fact that, look at this here. What I said is that I said, if I have got a growth period and the recession period, what I tend to find is that the covariance matrix 1 and 2 are going to be different. That is, the correlations are going to be different, but also in a recessionary period, what I know is that volatility is higher. So, in fact, one of the questions I'm asking myself is there something relevant to try to segment my periods into different periods? Not assuming that on average there is one correlation matrix or one covariance matrix, but assuming that that can change over time. Okay? So I'm introducing some sort of time dimension. One of the things here, it is a big assumption, it's a big question, because so far in this, and we didn't talk about that, I've been making the IID assumption. IID is the fact that period t plus 1 is independent from period t. Okay? Or t minus 1 doesn't bring any value to t plus 1, something like that, because in fact the information, it's a random movement from period t. So here I'm going to relax this idea of independence of IID and trying to look at whether there are some sub-periods that I should consider in order to understand the market better. So, in fact, there are different things I'm going to test. So the experiment is this. It is written here. I am looking at a target expected return of 5%. I am using a mean variance approach for in-sample, out-of-sample. I am going to use 3/4 of the observation in-sample to estimate the remaining 1/4, corresponding. So I've got in total 20 years, 15 in-sample and 5 out-of-sample. The mean variance portfolio allocates a big chunk, given 5% is not a lot in terms of return, okay? So it's normal that it allocates quite a lot to bonds, 58 plus 1.8, 6.5 to commodities, and 33 to hedge funds, and nothing to the equity asset classes. Now, when I look at this over the last 5 years, I'm getting a 1.5% return. Okay, so which is highly unsatisfactory. So the question I'm going to ask myself is this a problem of not considering fat tails? Okay, a lot of people talk about fat tails. Fat tails are important. So what I'm going to do is look at one thing, which is, are the returns not well distributed, so not Gaussian, and with fat tails? Or is it the case that actually the moments, so if I take the first moment as the return and the second moment as the volatility, they tend to change over time? Is actually the fact that I misestimate the out-of-sample return? Is it the result of not understanding the returns properly? Or is it the fact that, in fact, from periods to periods, the moments characterizing this distribution tend to vary? So, first experiment is I take all the asset classes to be characterized by their mean and variance during the in-sample period. There is one mean, one variance for each of the asset classes I'm considering, estimated over the 15-year period. Okay? Second experiment is I'm considering that, in fact, the mean variance approach is not sufficient. And therefore, what I'm going to use is I'm going to use typically a student T approach to allow for fat tail. Okay, to say they can be, instead of having for each of the assets a bell curve distribution, what I'm going to do is I'm going to say, well, in fact, the distribution of the assets over time. So if this is the bell curve, what I'm going to say is, in fact, the distribution I'm going to have is a distribution like this with a fat tail here. Okay, so allowing for big losses. Then what I'm doing as a third experiment is to allow for even fatter tails, where I'm saying here it's going to be like this. So really, the probability of extreme losses has increased significantly for each of the asset classes independently. Okay? And then I've got a fourth experiment, which means that instead of looking at the mean and variance on the periods of 15 years using monthly data, what I'm going to do is to estimate the mean and variance with a rolling window of 36 months, and saying that the mean and the variance is going to be adjusted based on the history of 36 months. So from one period to another, I will allow for the mean and variance for each of the individual assets to vary based on my rolling window. Okay? So which one is going to yield the best, the most interesting returns? In the sense that what I would like, it is interesting if in the end I'm able to get a level of return out of sample of 5%. You know, I was with 1.5. 1.5 is the worst. Does it bring, and it corresponds to the first experiment, can I add value with the second and third experiment and the fourth experiment too? Here are the results. So, in fact, when I look at the out of sample with this, in fact, when I use the simulated means, I can only, you know, the assumption basically is this. It is the fact that I have been considering that it was to yield 5%. Basically, it is theoretically yielding 5% on the simulated data, but I cannot explain what I'm getting 1.5. I don't understand what is going on, okay? Because based on the assumption that I've been considering, I can only, based on the history, I can only get 4.6%, close to 5% based on the data, and I'm not able to get the idea that I can get 1.5%. It is ununderstandable. There is no way. What you can see is that when I am actually using skewness, it doesn't help at all. It is helping me in no way. Why? Because I'm still making the assumption, I'm making the assumption that these assets, although they are skewed, it doesn't change their correlation. Okay? So in fact, asset 1, when it is here, doesn't mean that asset 2 is going to be here at the same time. So in fact, I should have, in order to have something that is a bit better, I should have, in fact, incorporated not only single asset skewness, but also co-movement towards a degree of correlation that is increasing when we're getting into extreme cases. Now, what is interesting is that when I get this rolling window with adaptive mean and variance, then I can understand much better why I'm getting down. It is because actually what happens is that the mean and variance in my sample are evolving. And assuming that there is a stable mean and variance is something that is completely wrong. So in fact, here, what happens is that the only way here I can explain something is by moving on a smaller amount of time and having, in fact, making decisions based on more limited history and with moving one step forward at a time with a view that has been close to a recent view rather than something which is taking a long history of time. Yes? In a way, you're right. You're benefiting from, well, wait a minute, because all the times, in fact, if we're getting one step further, whether you're taking 10 years or you're taking 1 year, you're always looking at momentum. The only thing, the difference is that you're saying that the momentum is with long memory or the momentum with short memory.
To agree with them, not necessarily in the sense that you are always just expecting the market to grow.
Well, I think there are two ways to look at it. One way is to say, when I am looking at an historical time series, I am looking at the long history on average. So that means that the momentum, in fact, there is almost no movement because, in fact, the market moves with a very long memory and doesn't move very, very quickly. If I'm looking a short period of time, I'm saying the memory used by the market is fairly limited. And therefore, the other thing too is that if I take a memory that is fairly limited, what I assume is that, in fact, I allow for big changes in the sense that if there is a period of, say, 3 months where the market collapsed, I'm saying I'm going to allow the market, for the market to collapse. Whereas if I'm looking at 10 years, I'm saying this blip during 3 months, I don't care. Okay? It's true that it is momentum, but the idea already, well, the two are momentum with different frequencies. But in fact, in this, it's more relevant to say that, in fact, I allow for the returns to be adaptive. And another way to look at it here is to say, this is time, and this is the return. Okay? Now, I am in 2005. It's a very stylized view. And here it's 2005, 2006. And then I'm getting into 2007, 2008, 2008, 2009, 2010. Okay? So it's a very stylized approach. But assume that I am saying that, in fact, over the long term, the return of this asset is this.